Okay, so let's try to understand the distribution of data a little bit more details. Okay, so you know that the distribution can be uniform distribution, it can be normal distribution, or distribution can be skewed. And skewed distribution is the more practical. Okay, most real world data set actually come in skewed distribution of data. So what does it actually mean? What do they mean? So a normal distribution looks like this. So it has a most of the point is centered around a point, that is the mu. Other point, there is this standard deviation, that is sigma. Okay, so there is a point how much of the data, how much percentage of the data should be within 1 sigma, how much should be within 2 sigma, there is a value. Okay, now this is called a normal distribution. So this is a normal distribution. What is the uniform distribution? Uniform distribution somewhat looks like this. Okay, so say for example from 0 to 6, 1 2 3 4 5 6, 1 2 3 4 5. Say if you six-sided dice, if you flip a six-sided dice, okay, so for example 10,000 times, the value that will get, you will see some, not zero actually, from 1 to 6 you will get a curve like this. Sometimes one is the, and they will be very close to each other. How many times you got 1, how many times you got 2, they will be very close to each other, and this is what is called an uniform distribution. Okay, this is the uniform distribution. But when it comes to real world data is something like this. Okay, skewed. Some value is very low and the most of the presence is somewhere here. Say for example, if you look at the house pricing, so what do we had? We had the room number here, 2 3 4 5, okay, 6. Now imagine when you are actually trying to collect data of house, the number of rooms will be mostly around 2, or say 1 or 2 or 3. Okay, it may be something like this. 3 is the most common. The number of house that we'll get for that has more than 6 rooms will be very low. So the data distribution would look something like this. So this is called a skewed distribution of the data. Okay, now the problem that actually arises is that the presence of outliers in the distribution of the data can shift the characteristics. What are the characteristics? Mu, that is the mean value, sigma, that is the standard deviation, then median of the distribution. Okay, these three values are affected by the presence of outliers. Okay, let's see how. If you come here, so y1, okay, this was the original data that we had. Okay, this was the original data, and y2 was the data that we changed. Here we just placed 23.5 and see how the other parameters are changing. Mean value of y1, mean value of y2. Just because we have changed only one point, see how the distribution will change. The mean value is 3.4, that is obvious, but here just for one value the mean value has shifted towards 6.27. Let's take another look. Standard deviation of y1 and standard deviation of y2. Now see, as you can see, for the first one standard deviation is just 2, and for the second distribution, for second y, just because of one value is too far, standard deviation is around 7.8. So as you can see, this mean value and standard deviation is very much affected by the presence of outliers, and that actually affects when you are trying to perform any regression analysis or similar kind of analysis. Okay, so the question is, how do we identify the outliers? Okay, a simple way to do that is use what is called a box plot. Okay, so let's see. Let's test here y1. Go to plots, just click it and go to the box plot. Click one. As you can see, this is the box plot for y1. It looks something like this. Okay, I will see. I'll describe what they actually mean. Now let's take a look at the y2 now. Let's look at the box plot. Now as you can see here, you can see there is a plus line. Everything is here. So what does they actually mean? Okay, let's try to understand that. So when you are creating a box plot, you see there was a box like this. Okay, there was this line something like this, and there was this small line something like this. Okay, right? Okay, then you had some a plus sign here. Okay, or say a plus sign was here, and there was a small line like this. So let's see and try to compare y2 again. Okay, so there is a minus line here. These are two. This is the line, and here you can see. Okay, let's see and understand what does it mean. So this one, this range, this one is called IQR. IQR. What does it stand for? IQR is interquartile range. Interquartile range. Okay. In short, it is called IQR, interquartile range. Okay. So these two lines that you are seeing, this line and this line, these are called whiskers. Okay. These are called whiskers. What do they mean? I am going to explain a little bit later. Then this plus sign that you see on the outside, these are the outliers. These are the outliers. These are the outliers. So using a box plot, you can easily visualize whether your plot, whether your data have any outlier or not, has any outlier or not. For example, for y1, when you see the box plot, you can see there is no outlier. There is no plus sign here. This is the median. This is the median value here. This is the this line is the median value. Okay. This is Q3. This is Q1. These are the two whiskers, and you can see there are no outliers. Okay. This one is Q1. This one is Q3, and this is the median distribution. This is the median of the distribution. Okay. Now, okay. Let's try to understand now. Let's try to understand what do they actually mean. What do they actually mean one by one? Now, first, there are different methods to identify the outliers. The first one, the most common, that is called mu plus 3 sigma. That means 3 standard deviation. So anything that falls within this range, the mean value plus minus 3 standard deviation plus minus within plus minus 3 standard deviation, these are not considered outliers. Anything outside that, greater than that, will be considered as an outlier. 2, that is Q3 in the box plus 1.5 IQR, interquartile range. Okay, and Q1 minus 1.5 IQR, interquartile range, that actually falls outside this range, that is an outlier. If you see the last one, as you can see, this is Q3 plus within this range, this is the 1.5 IQR. This data point was outside that. That's why it is actually marked as an outlier. Okay. Then what is the third one? Then there is the third one, that is called the median of the distribution. Okay, plus minus 3 of MAD, median absolute deviation. Okay. So, however, we don't have to go into details. This one is the most useful one. This is also very useful, but this one is not. As you can see, mu value and sigma value both are very much affected by the presence of outlier. So you don't use this normally. You can use these two to identify whether there is an outlier in the data or not. Okay. So how do you actually do that? There is a function in MATLAB that is called isOutlier. Very simple and easy function. And you know, this is before many of the terms, just by pressing is, you can do lots of tasks in MATLAB. So let's see. Let's come here. Live editor, section break. Okay. If I write isOutlier, which one we want to find? Say for example y1. Let's place it again. isOutlier. Where is y2? Let's see. Yeah. Let's run it again. As you can see, when it is doing isOutlier y1, there is no outlier. In the first one, there is no outlier, but in the second one, it is giving you a logical array. The fifth data, that was the fifth data, and it is showing that there is an outlier. Okay. So let's go dive a little bit deeper. So let's write isOutlier y2, comma. As you can see, these are all the methods to identify outlier. Okay, this is optional. So as you can say, mean, median, move mean, move median, quartiles, then GSD, these are alother method. Let's press mean. Now let's see. As you can see, when you press the mean, that means it was using this method. And when you are using this method, as you can see, the outlier is not detected. So using mean, if there is a presence of outlier using mean, you may not be able to find the outlier. So what it is using by default, you can check here, is outlier. Find outliers in the data. Come. Okay, as you can see, by default, an outlier is a value that is more than 3 scale, that is MAD. That means this is the default operation by MATLAB given. Okay, so this is the default operation, and using the default operation, the MATLAB was able to identify the presence of outlier. But when you use the mean value, it was unable to do that. Okay, there are other methods like percentile, anything that does not fall within the 95% range of the data, 95% distribution of the data, that can be considered as an outlier. So once you have this outlier, what you can do, you can just remove outlier. Okay, so let's say y3 is equals to y2, but not is outlier y2. So if I do it like this way, as you can see, the outlier is removed. Okay, you know, this is a Boolean masking operation. I believe you should be able to understand this by now. So when you are performing any linear regression or similar kind of task, you have to remember that if there is an outlier, first remove the outlier. You can use any of the method, but these two are the best method. This is the default one. You can also use this one. There is also quartile method, that is when you have a very large amount of data, quartile method is very good, and you can use 95% quartile range. Okay. Anything that does not fall within this range can be considered as an outlier. Okay, that is I use it normally. Okay, so any other thing? Okay, now, so this was the main thing. Now one other thing is that so far we have talked about actually linear regression. Linear regression means the data that we are showing, the data that we are representing. So the data was like this. This was the trend of the data that we show. So the line that we are drawing, was something like this. This was a linear line. But what if the data is a little bit different than this? Say for example, okay, and the data points are something like this. Okay, what do you do then? Can you plot a linear line here? As you can see from just by the visualization, you can see the line, that is our desired line, should something like this. It should be the distribution of the data. Okay, the distribution of the data does not have to be linear. It can be a non-linear data as well. So how do you do that? Very simple. Instead of a linear equation, you are fitting a linear equation here, y is equals to mx plus c. What you have to do? You just have to fit a polynomial equation there. Say for example, y is equals to x square, something like this. It can be x cube plus ax square plus bx square. Okay, it can be a higher order polynomial. Using higher order polynomials, you can easily fit any kind of shape. Okay, say for example, if you have a shape something like this, if the shape is like this, so just from the distribution of the data, you can guess it should look like a something like this, a circle, and you know the equation of the circle, that is x square plus y square, okay, is equals to r square. Okay, so this should be a circle. So for different distribution of the data, you have to use higher order polynomial, that is nonlinear. Okay, nonlinear curve fitting. You have to fit a nonlinear curve. Okay, and you can also solve it. Say for example, if you come here, even here, yes, as you can see, this is a nonlinear curve. When you want to fit a nonlinear curve like this, you will have a set of equation like this. You can just use a matrix multiplication. A is a matrix, then x is a matrix, then y is a matrix, then you have to take the inverse of x. So it is something like this, x inverse into y, that will give you your theta. But as you can see, x inverse, taking inverse, those of you who know about matrix inversion, this is a problem, and that was the problem with the algebraic method that I actually talked about earlier. So let's just keep it here.